Lovely to be here. Thank you for joining us. I will be sharing a story from our experience as part of the Enterprise Item Systems team at Target. So quick show of hands before we get into the session. How many of you hear how many times do you hear Gen AI every day at work? 6 times. Okay. Higher? 6 times? Yeah. Okay, cool. 12 times. Okay, cool. So that's kind of the I'd say what I hear every day, and I hear it from not just data science and ML practitioners. I hear it from front-end and back-end developers in our teams. I hear it from team members and leaders in operations, product, and business. I hear it from C-suite leaders, right? No other technology paradigm has generated so much interest in recent years, right? A lot of that excitement I see translating into ideas and ideathons, right? Like there are Gen AI focused ideathons. Some of those ideas are translating into POCs, some POCs into pilots, right? And I suspect some of those pilots will make it live into production, right? And add value to our users, customers, and businesses. I see that at Target. I suspect many of you will be seeing that, experiencing that in your businesses in whichever domain your business operates in. So you kind of wonder, is this session about Gen AI? I saw that there were 15 other sessions about Gen AI at GITS this year. This session is not necessarily about Gen AI. Here's what we will cover. I will tell you how it's related to Gen AI. But here's what we will cover through the session. Few seconds to guess what this was. Okay, it says my last delivery, so not much of a guess. This was I order a lot online, right? I'd say from toilet paper to my flat screen TV has been ordered online. This was my last delivery. A small item in a really, really large package. Now, you're still wondering, okay, what does Gen AI and this have to do with this session? So I mentioned that, and he mentioned when introducing me, that I am a part of the Item Systems team at Target. Item is a physical construct in retail. What does that mean? As a retail business, we plan and buy items from vendor partners. We move these items from some source location somewhere in the world to a Target-operated facility in the United States. We help our guests or customers discover these items through a multitude of channels, including our physical stores or online channels. We help sell these items to our guests. These items are sent from a facility that is closest to our guest for quick delivery. The items can reach our guest at their doorstep, but they can also collect it at any of our stores. We also facilitate return of items at our stores or from our guest's doorstep. So you've heard me say item, item, item. So retail is a lot about item, right? Physically. What do we at Enterprise Item Systems team do? From a systems perspective, engineering perspective, item is an encapsulation of all of the data and all of the business rules which are associated with that data, and that fuels all business processes for a retail organization, and which we spoke about, and some of the non-retail processes that any business needs to work with at scale. Now, we'll talk a little bit about some of the retail business processes that kind of you and I as guests or customers see. Product discovery, right? Like serendipitous discovery of products. We say internal search when you're on our website and look for an item. Or you could come through an external search engine, right? So if you land on this page by looking for something that is powered by item information, confidence to buy a product. So everything that you see on the screen, right, from the title, which is highlighted, because I will talk to title and models that we have for title later, to anything else about the color or the images, right? All of that is associated with the item. The size chart, the material, returns policy, shipping policy, all of that, right? Now, for the physical item, which is a shirt, this is the item data or a subset of the item data that could actually fit on this presentation. You see title and color highlighted because I will refer to it in my presentation. Target sells laptops. So again, the title for the laptop is item information. Because laptop has a lot of specifications running into pages, we condense and summarize that and present as highlights, again, associated with an item, right? Dimensions of the laptop, right? Like weight, width, height, etc., right? All associated with laptop and item. Now, we are a multi-category retailer. We sell everything from baby cereal to dining tables to t-shirts, right? And you will see that all of this is item information. We call them attributes. There's not much of correlation between, like, item information for baby cereal to dining table. So this is the universe of item attributes that we have at Target. And you will see the business processes that it powers. Now, we sell different brands. We have our own private label. So we design and manufacture those items. And we get them from all around the world, right? So we get this item data or attribute from a number of partners, right? And some external, like our vendors, and some internal. Now, why is item data important? We saw that picture, small item, large package, right? Because item data influences everything from a business process perspective. So if item data is set up incorrectly, like let's say the product title is not correct, right, or is not appropriate or full, it could affect external search, and an item might never be discovered, might never be purchased, right, which affects our revenue. If highlights are not correct, right, or not full, it affects purchase confidence for our guests, so an item might not be purchased, right? So both these affect our revenue and top line. If setup of attributes is all manual, it takes time. So it takes us time to launch items and make them available for our guests. Obviously, it is operationally suboptimal to set up items manually or to enter all of that information manually. If package dimensions is incorrect, you would have small package, large container, right? And it's bad for the environment. So when we first digitized item, we had systems to collect, create, maintain, curate, enrich, and publish information to all of Target for it to be available on our website and apps. But a lot of it required some kind of human touch or human intervention at some point in the life cycle of that item, which meant that it was operationally inefficient and the data was not always right. And so as a first step, we introduced a rules engine, right? Like a simple rules engine. Now, there is only so much that a rules engine can validate and help you correct. Now, you've seen the variety of information attributes that we have. We realized that having just a rules engine will not be enough if we cared about the quality of item data and the business processes that it powers. So that's where about maybe 4 or 5 years back, we started exploring use of machine language, or I would call broadly intelligence in item. These are some of the reasons that we use of purposes for which use ML models. Anomaly detection. We actually have a tool for detecting anomalies in package dimensions, which ensures that items are sent in the right sized packages, reduces shipping cost and is good for the environment. We extract structured information from unstructured. Color is an item attribute. It's available in the description. It also needs to be available as an attribute, for indexing on search. externally and internally. So sometimes when it is set up manually, there would be inconsistencies in the color in the attribute and the color in the description, right? So we extract information. Color is an attribute that we extract from unstructured data that we have. We use it for labeling images and so on. These are some of the models that we currently have in production. We have over 20 of them currently. A majority of them are classification models, but we also have other kinds of models. We have some vision compute, we have some segmentation, and we've just started using some large language models. So I mentioned earlier that item has over 3,000 attributes because of the diverse category in our catalog, right? Now, even if we were to have models for a subset of those attributes, that's a lot of models. Many models, each model depends on one or more attributes. Each attribute kind of influences one or more models. So we kind of have a many-to-many relationship between our models and item attributes. So even before GenAI, while we had a handful of attributes, because of the number of items in our catalog and the change to the attribute value of that item throughout its life cycle, when we had models operate on those items, we actually had a lot of model-generated output, right? Like any inference or prediction from a model is model-generated output for us. And we had quite a lot of them. And even prior to this year, we would have had, say, 4 to 5 million inferences a year. This is all pre-GenAI. So this is the future that we were looking at almost like a couple of years back. Like it's kind of a Cartesian product of number of items in our catalog, kind of the number of attributes that we need per, say, item type, and like a rough percentage of change that some item attribute for that item might undergo a change, right? So we were looking at millions of inferences or model-generated output. So what do you do when you have an explosion, maybe not of ML models, but of model-generated output? We had a domain ecosystem, right? Item has a domain ecosystem. It's a slightly bit complex one because of the number of processes we influence. We have like several microservices, but nevertheless, that ecosystem had to kind of accept all of these changes at different points in time. Now, ML ops, we actually have a customized ML ops toolkit. We follow practices and processes, ML ops practices and processes for item. And it does all of these things, right? It helps with design, model development, and operations, right? So we had optimized the life cycle of models. We had optimized the operations of models. But the challenge that we had is we hadn't done much about the existing operational domain ecosystem that we already had. Which is why we kind of went to the whiteboard and then started having conversations on what should we do to make this integration and assimilation of ML-generated output seamless. And we came up with this thing of, we need an applied ML framework. So what is applied ML? And how is it different from ML ops? ML ops focuses on the model. The primary focus of ML ops and all of the toolkit is on the model, right? We believe that the focus of applied ML is on your current domain object, right, or ecosystem. Just like how ML ops will make the ML lifecycle, the lifecycle of a model efficient, you need something to make it efficient for the operational ecosystem to accept these changes coming from ML models. As we started discussing this at length, these were some of the considerations we felt we had to take into consideration to apply ML at scale for the item domain. We will have different kinds of models. You've seen the variety of attributes. We will have different kinds of models. We already had different kinds of models last year. We wanted to be agnostic to the type of model, right? Model development time. Model development takes time when you're building it in-house. Data science is a niche skill. We could always do with more data scientists. We have more problems and opportunities in item than we have data scientists to work on them. So we wanted to be open to using external models. As we explored external models, we also realized that external model providers have access to a lot more data when there is no domain specificity than Target has. And we wanted to leverage their access to that data. So obviously, we wanted to work with different model providers, right? Like small, medium, and large. Latency. Latency is a factor in adoption, right? Especially as we started working with both internal and external model providers, internally and externally hosted models. As we had different kinds of models, some models are just computationally more intensive, right? So we have models whose response time is anywhere between, say, a few hundred milliseconds to over 10 seconds. That was something that we had to keep in mind while generating the ecosystem for adoption. Cost, both indirect and direct. Direct is when you use external models, there's some kind of a per API cost associated, with each call. Indirect is when, for our own models, there is computational cost. And confidence to apply at scale. This is quite interesting. We were transitioning an organization which was used to high-touch setup of item data to a model where there is lower touch, right? More automated, ML-influenced automation, but more automated and autonomous setup of item data, right? We realized that is a journey. Now, confidence of ML models in item is quite interesting, the confidence score itself. ML models for item influence item data. Item data influences some business process, and that business process could be way downstream. In the case of the package dimension model, it is the last mile fulfillment, last mile, right? It influences a process way downstream to when the item data was changed, the package dimensions was changed. So a lot of the times, the confidence on the model depended on the blast radius of the process, of an incorrect process that would result from incorrect data that the model would predict, right? Way downstream. And the impact. Would be sometimes reputational. In the case of package dimensions, it is like our operational cost, if it's incorrect. It could be health, if it's nutritional label for like baby cereal, right? Or it could be revenue, if the title or highlights is not appropriate. So we realized that we needed to have a trust framework which kind of took this into consideration. So not just during the time of training the model, but well after the model is kicking and alive in production. So these were some of the things that we wanted to build into our applied ML framework. To my left, is it my left? Yes. No, sorry, it's not my left. To my right, okay. So to my right is the domain or operational systems for item. We have a number of systems because we have a lot of attributes. All item attributes are centrally aggregated, which we call item publish. And then that is what feeds all services at Target. And those services might in turn feed the end consumer. So that's what you will see on the web or app at Target. To your, whatever that is, right? Basically, you see the applied ML framework for item. And we have a couple of core components that I will talk about. The model orchestrator is one of them. And the decisions manager is another. We'll kind of go through this flow with with a real live example, and then maybe I will talk to what each of these components is responsible for. Let's say a vendor partner changes. We saw a pink color shirt. Let's say they change the color from pink to peach, right? Now, we want the title to change from pink to peach because that will influence external search, results for external search. Now, this gets published to the item publish system, like the entire item record. The changes, the atomic changes, are also published centrally. The model orchestrator actually listens to these changes and it builds the model workflow for this attribute. The model orchestrator has a dependency graph between attributes and item and specific models that need to be executed. We do that because we don't want to run all models all the time. We have far too many changes. We don't want to run all models all the time, like even if they are internal, right? So this dependency graph helps the workflow builder decide which models have to be run. So the workflow builder now knows that title has to be run. Highlights is another like item information that is influenced by color. So like the workflow builder will run title model and highlights model. They are both external models. It knows that they can be run asynchronously. It knows that they can be run in parallel, right? Like there's no model chaining between title model and highlights model. We do some post-processing for a lot of models. It knows what those post-processing needs to be. There is some kind of validation we do for any language model. It knows what needs to happen for title and highlights models, and it'll chain them, right? Now, then the models obviously, return with the output whenever they do. Let's say title returns first, right? And you have the generated title, which reflects the change in color for the shirt to peach. Then it passes it on to the decisions manager. Now, this is the other kind of key component that we thought about a little bit. Models have probabilistic outcomes. We didn't want everyone to deal with probabilistic outcomes, right? And we wanted to have different confidence thresholds for different models. And for us to be able to change that, not runtime, but at some time during the life of that model, right? All of that is part of the model orchestrator. Now, the decisions manager is responsible to convert a probabilistic inference from a model to a deterministic change for the item. In the case of title, we've agreed with our business that it's okay to change the title attribute for an item, which is generated by a model. So the decisions manager will issue an instruction to the source system to change the title. In the case of highlights, we are less confident yet of the model's output. So it is not approved for what we call auto remediation, right? So the decisions manager will send an instruction to flag the new highlight to the end user. So a vendor partner might actually see this, the new highlight with a flag as recommended by the model. They can accept or kind of override it. Now, if they override it, again, it goes through the entire process and we know that, okay, this has been overridden. So we will not generate highlights for some time, for a period of time, right? So the key responsibilities of the model orchestrator become like it is the sole interface for integration with any model for us, like, internal, external. Right? It caches data, like, sometimes we don't want to run models all the time. If there's not significant, what we call change to the data, that is something that it maintains. So it kind of reduces running of models unnecessarily. It does, it runs models judiciously. It basically chains models if they have to be chained. It would also batch run models for changes or batch changes for executing some models. So all of this is basically taken care of by the model orchestrator. So we said, hey, we wanted to take care of these considerations. One change we did do to our source systems is, like all source systems which want some kind of human judgment, where where the decision that we recommend should be looked at by a human and then either accepted or overridden. That is the only change that source systems had to make. So by making some of these changes, mostly abstract, kind of finding abstraction layers and centralizing some of these decisions, we kind of took care of the challenges and some opportunities that we foresaw. So when we had to integrate with LLMs, the only change to integrate it at scale, of course, we had to go through POCs, pilots, etc. But the only change that we had to make to integrate it at scale was to the model orchestrator. Now, of course, the model orchestrator had to deal with an LLM interface layer because there is some processing that we want to do at a central level for LLMs. That was the only change that we had to make. So hopefully now, you might kind of wonder, okay, is this only a target problem? Is it only a multi-category retail problem? Does this happen only when you have a large data set? Now, I think that's where GenAI might kind of make the difference. While it is applicable only for language-based models at the moment, with the acceleration, with the pace of change of AI, it's very likely that many more types of models could get democratized. Model development time itself could get shortened. So with GenAI and other such enterprise language models, shortening model development time, like giving us a Swiss Army knife, right, where it could do a lot of things. You just need the problem or the opportunity. With ML ops, shortening the model operations and operations time and efficiency, making it more efficient, we believe you need an applied ML framework. Most of us will need an applied ML framework to make adoption seamless and integration easy to apply ML at scale. The reasons that you might get there are different from the reasons that we did. And I hope that, but nevertheless, the why and the what are not that far away for many of us. The implementation itself is probably specific to target. What I hope I was able to do by sharing our story is to impress upon you to think beyond ML ops of what other challenges could be there to adopt ML and ML generated output at scale. Thank you so much for listening.